Everyone, my name is Yuanyumeng Zhu, and today I'm honored to present our research title Bridging the Education Gap: Advantage Resourcing Allocation in the Appalachian Regions through AI-based optimization. So this project addressed a critical issue: educational equality in underserved regions and how we can combat it using artificial intelligence. The core focus of study is to apply deep reinforcement learning and logical optimization framework, especially the heterogeneous capacity vehicle routing problem or HCVRP to improve how educational materials are delivered in remote areas like Appalachian. The purpose is not just statistical optimization, but to support the United Nations Sustainable Development Goal 4, which calls for inclusive and equitable quality education. Let's first understand the core problem. In the Appalachian regions, isolated geography, return to return, and the economic hardship make it difficult to get learning materials to studies on time. Roads are often unreliable or reasonably blocked, and many schools are underserved. Traditional logic strategies like learner program or grading routing struggles in these real-time, uncertain conditions. This results in delays, inconsistent access to textbook, and teacher shortage. The consequence is clear: a deep educational gap that limits not only academic performance but long-term regional development. This is not just a local issue, Globally, over 260 million children lack access to basic learner materials. Solving this in Appalachia sets a precedent for broader impact. To address this challenge, we reviewed the research from five thematic areas: educational transport equality, natural network-based logicals, and public policy interventions. Studies like those by Gradikins and Brumbaum highlight the disconnect between transport exercise and educational outcomes. Others, such Political, shows how AI can enhance logicals. However, few studies bring all of this together: AI educational policy and the delivery logics in a public service context. That the gap we aim to fill. We adopt a maximalist approach. Quantitatively, we build model using NCES school data and Google Maps traffic. Enhanced which elevation data, we formulate the logical problems such as Markov decision process, optimized through a DRL encoder-decoder architecture using learner form attention. Quantitatively, we conduct interviews with teachers and the policymakers. Focus group and case studies help us identify optional realities such as infrastructure regulations or lack of digital access, which informed the AI model design. This two-way interaction between data and stakeholders' feedback is what makes our approach context-aware. We hypothesize that the DRL-HCVRP model will significantly outperform traditional methods like SISR. Earlier simulations shows promising results, lower delivery costs, more balanced routes, and the shorter delays. Feedback from educators confirm that our model aligns better with real-world challenge. Peer studies support this approach, and like previous et showed how deep learning improves that delivery in which turns our adaptation built on such insights but tailors them to public educations. Of course, there are challenges. Real-time data like traffic APLs may be unstable. It can be difficult to coordinate interview in remote schools, and many schools lack the hardware needed to run AI models. Our model also has limitations. It was trained on simulations, so it may not functionally capture real-world variabilities, and while focused on application, it may not generalize the global without retraining. To address this, we propose the local clouds programs and expand simple deliveries across the different regions. We also compare our models against the multiple baselines and conduct additions studies to ensure robustness. In closing, this project demonstrates how AI can be used not just for corporate efficiency but for public good. By combining deep learning with local insights, we've built a system that learns not only from data but from people. It offers a scalable model for achieving education equality in underserved regions. Through this journey, we come to better understand the ethical and teachable complexity of applying AI to social problems. I hope this reach can serve as a blueprint for others who wish to merge innovation with impact.